Okay, so this is really this is a learning objective 10 for the NABCEP entry-level exam. It's also chapter 14 from our textbook. So I'll just read the chapter objectives. Describe the steps involved with commissioning a system, identify the maintenance tasks involved with maximizing array output, develop a maintenance plan based on system configuration, develop the various methods for monitoring system parameters, and then troubleshoot based on a logical and efficient process. So the point is now you've got the thing ready to go. It's got to be commissioned, put into service, then it's got to be maintained. If something breaks, then it has to be troubleshot. So this is important to know. It says once a system has been installed, inspected, and approved, then it's commissioned. So it's going to be critical to know that commissioning happens as sort of the final step after all these other things happen. Commissioning is also the time when the installer formally transfers responsibility to the owner or operator and marks the completion of the installation. Any warranties or service agreements should be finalized at commissioning. So this final checkout before any PV system is fully operated for the first time. The system should be checked thoroughly to ensure that the installation is complete and it is safe and ready. Pre-commissioning checklist, sitting right here. On page 309, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pre-commissioning checklists. So, you're the contractor and the commissioner's about to come in. You do this ahead of time, so when he comes in, his job is easier. So the installation conforms to system design documents. You don't have drawings with 14 panels, then the system has 16, for example. Structural components installed. You don't have screws that are. Sounds like when you guys were installing in Bozeman, you missed a few of the rafters. There was some discussion. Oh, yeah. So and if you had a few that missed, you don't really want those things sticking out either. So that stuff gets tidied up. Equipment is properly listed, identified, and labeled. So if there's a big switch that the operator is going to use frequently, that needs to be labeled. Conductors are appropriate size. We just had that the other day when we were finalizing the array on the trailer. We needed number 8 non-stranded wire and called around a bunch of places, finally got some, but you do not skimp on wire. That's how things get hot and burn. Terminal connectors, tight, properly identified. It's all inside boxes and races. The trailer's great for that. Equipment securely mounted, nothing to trip over, fall on your head. Array mounting system is secure, obviously. Roof penetrations are properly weather sealed, caulk, what have you, flashing. Safety measures, safety features are installed in operation, are operational. Again, there's a shock hazard, safety labels are in place, and also the automatic grid disconnect needs to be functional. Applications warning and operation labels posted, calibration and set points for inverters, so that you're not overloading your inverter, overloading the charge controller. And I think a lot of times it's from what I've heard, the inverters are usually the first things to fail on these things. The PV panels kind of keep doing their things, but I think that's what we're going to see here. Job site clean, neat, orderly. Obviously, documentation package is complete. Here it is, a big folder. Disconnects are open, fuses removed, and lockout tags in place prior to commissioning. And so the lockout just says that you can't come in there and touch it without the proper keys, and we've done that. So a third party doesn't come in and injure themselves. Okay. So I'm just looking at figure 14.2, and there's sort of a step-by-step set of processes, and this will become second nature as you go through it. But the first step is to connect the battery bank to, if you have one, to the charge controller. Everything else is open at this point. Then you're going to close the array disconnect, so the array will now be able to, from the combiner box through the charge controller. Then you close the charge controller, which talks to the batteries as well as the inverter. Next thing is to close the AC disconnect, which will get you to the utility, and then finally you close it to the load so that the things in your the items in your house are energized. So I would know that order. Yeah. So you don't turn the load on before the energy source is ready to go. Continuity and resistance testing. That's just making sure. I mean, you can visually inspect the thing. It looks like all the wires are in place, but unless you've got your multimeter out there, you don't necessarily know that you've got good continuity. And it's also going to be important to verify that the voltage drops are what you expect. There's always some resistance, and it's not going to be good enough to say, yeah, I have continuity. Because if you've got a poorly connected wire in there, you could have continuity, but a big voltage drop somewhere that's hampering the performance of the system. So I'm sure there's going to be a question like that. Polarity testing. I mean, systems will work with the polarity reversed. In fact, I've found reverse polarity lines even in this lab, but that's a big no-no. You cannot have your hot wire attached to your neutral. That's what I mean by polarity testing. Same thing with your DC system too. Voltage and current testing. It says prior to closing the PV array, the open circuit voltage should be tested. So the sun's shining, test the open circuit. Each panel is getting the proper amount of voltage. Insulation resistance. So this is by applying a constant test voltage to a conductor and measuring the current flow between the conductor and ground. All of the current should be going between the current and the ground, not somewhere else, leaking out through some improperly insulated portion. Most likely to happen in some kind of combiner box where the wire nut's not turned down, or there's some little funny wire or chunk of dust touching and setting it to ground. Commissioning test reports. So each one of those commissioning steps is going to have a check mark by it, as well as a note, maybe even a photograph. I'd be surprised if this is on the exam, but it might be worth your while to go and look up the IEC 62446 standard. And then finally the signatures once all of these tests have been done. Okay. Now, I'm just going to look at this maintenance safety thing, page 403. Something quick? Good. Maintenance safety 3. This is just before the customer walkthrough happens. It says proper safety precautions must be taken during all aspects of PV system installation, operation, maintenance, and troubleshooting. These tasks can expose personnel and electrical, chemical, explosion, fire exposure, and ergonomic hazards, meaning just bending, hitting your head on something. Qualified persons have a thorough knowledge and understanding of the equipment and procedures involved, and the skills and knowledge to recognize and mitigate the associated safety hazards. So be they mechanical, chemical, or electrical. Most likely electrical or mechanical in this case. Specific safety regulations and standards required for construction and maintenance that are covered in OSHA regulations 1910, and 1926. And those are courses that are offered 2 or 3 times a year through the college. And NFPA 70. So we cover NFPA 70. That's just National Fire Protection Agency Code 70, which is the standard for electrical. And it's mainly just making sure that your electrical system is not setting things on fire. Depending on the system and the task, special tools and equipment are required. So personal protective. You guys wore that in Bozeman when you were on the roof, all that good stuff?
Yeah.
Yeah. Fall protection,
yeah.
Perfect. Face shields, safety glasses, footwear. And then, do we have a fire extinguisher for the, do we have one in there? Great, yeah. Perfect, yeah. And this is critical. Highly recommended to work with a partner, especially around hazards. Especially if you've got an electrocution hazard, that'll save your life. Okay, and then finally, once the pros have been through and you're happy, you do the customer walkthrough so that they are familiar with the operation of the system and any potential hazards. Keeping people away from it. And we were trying to do something similar down at Brennan's Wave and put a solar panel out there, and the city said, well, we don't really want it. And, the more often I'm down there, the more I'm like, well, what would happen if somebody hurt themselves on the solar panel? It's not really the solar panel's fault, but on the other hand, it was there, they hurt themselves on it, and then you've got an issue. So, and, there's similar issues coming up with the new building, which will have solar PV, but then if students are given access to that and something happens, you've got your legal issues. And that was really our motivation for building this mobile trailer. So we're all contained, relatively low roof, but just enough to be able to get the full experience. Okay, so system warranties. And there are a lot of things that can go wrong. So the modules, the inverter, the charge controller, the batteries, and it's just going to have some length of time. And and really all of these are based on time and money. What it costs to replace the thing, and the manufacturers in general are going to know how long they last and sort of hedge their bets so they're not losing money by over warranting something. But it says that the installer needs to go over that with the owners and ask them whether or not they want a extended warranty or not, just like an insurance policy. Okay, maintenance, as stated here, most systems require relatively little maintenance, especially if you do it right the first time. But if you're, right after a windstorm, hailstorm, not a bad idea to go up there and, check to make sure everything's still tight. You don't have loose wires or connections.
Lesson learned in Browning, keep your stuff away from unauthorized people. Have your system sealed up so people can't mess.
Yeah, that's a good one too. And I mean, it's a tricky thing because really what we're trying to do is we would really like people to have access to this technology. But on the other hand, the uninitiated go in there, start messing with it, walk off with parts, tools that are critical. So there's a fine line between education and
For a homeowner, if they want to monitor it, most of the grid tie stuff out there now has a network connection, so you can plug it right in.
Yep.
So you'd be well advised, rather than have the customer sitting there pushing buttons on their inverter where they may inadvertently get into a table they don't want to be in, it's much easier to have a monitoring system that they can look at on their laptop,
Yep.
their home computer, or their phone,
Yep.
and then they don't have to touch anything.
Yeah. Something's wrong, panel 3's down, call up
The
maintenance.
computer will tell them, yeah,
Yep.
and they don't need to punch
Yep.
buttons.
Yeah. We've got that on our trailer too. So a few things can happen. It says there's a couple examples of physical damage. There's an impact from impact from some, I don't know what that is, hail perhaps. It looks like it's pretty big. Maybe someone threw a rock up there, or a basketball, or who knows. Delamination is another one. We saw that on our solar car, where you get, the two different materials get hot, and when every material has a different thermal expansion coefficient, so when one gets hot, one will stretch or strain. That'll cause delamination. You can see burned connections. That happens as well if you've got too much current flowing through one particular place in the array. Corrosion can happen too, either at the fasteners or the array. Corroded grounding connections. If you're out in the salt water, living near the ocean, that could be an issue. Trees are mentioned, either shading or branches coming down, and then periodic shading or soiling. And I've heard of some panels that actually will generate their own electrostatic charge and sort of repel dust, but
And then we found out the panels that are on this trainer
Yeah.
are a special coating, kind of like some TV screens have, and you don't wash it, you don't do anything of using chemicals, you'll wash that off.
like
That
putting
coating-
Scotch-Brite on your pants, you want to just spray it on there and leave it there?
Yeah, so they're really super durable, and that covering is a protectant. You can hose it off or rain,
So don't be wiping it.
but don't be using the chemicals on it, because if you look on there, one of our panels has streaks where somebody
Oh,
tried to wash something off, and now they're marred.
interesting to see if that affects performance. Oh, it also says damp leaf debris can get caught under the panel. That can lead to premature roof damage or leaking. So there's cleaning under it seems more important than cleaning over the top of it. Cracked or deteriorated weather sealing. Nothing lasts forever. They're gonna break eventually, but just kind of keeping the connections from corroding is a good idea. Battery enclosures, the ones shown here on page 408, figure 14.9, shows that they're all well secured. They're not going to fall off the shelf. If this were, built to California code, you probably would have to make sure that even in the small tremor, they're not going to slide off, so you actually have lips around the shelves of your batteries to keep them on the shelves. Battery terminal cleaning. Battery terminals corrode. Keep them clean.
It's like $3, especially if you install that thing brand new, so everything's already shiny.
Yeah.
It's like $3 for that little spray can of the stuff, and
Mhm.
it's clear, it's almost like clear fingernail polish or something. That stuff lasts forever, and you won't have any corrosion, because there's no oxygen into it, so it can't oxidize.
Electrolytes can leak off from batteries, so that's another maintenance, just making sure that the battery's in good shape with topping off the electrolytes. And then battery watering. And there's a little table here, figure 14.3, might be worth noting that the greater the charge, the greater the specific gravity. So you've just got more ions floating around your water. It's just denser when your battery's fully charged. And your open circuit voltage is above 12.6. I'm experiencing that right now with our 5-gas analyzer. For some reason, it's not hitting 100% charge. I don't know why. It's just sitting there at 95 or whatever, and it's only at 12.4 or 5, but we'll keep it on. So again, it's impossible to keep the thing at exactly 12 volts, but you need to be above 12 to drive a 12-volt system. Once you get below that, you're in trouble. So there's an Archimedes, which is a little buoyant hydrometer, and there's a refractive index, which is an optical hydrometer for looking at specific gravities. 2 different ways to check your electrolyte level. So there's a battery load tester, which will see, if you hit that battery with a high load, can it really sustain it? Because you might be at a high voltage, but there might not be a lot of capacity left in the battery. So, how long can it sustain a high load, especially if you've got multiple appliances coming on at once. Capacity tester just looks to see how long it takes to fully discharge the thing. We just got a nice little IR thermometer, and that's looking to see if your system's running hot. I mean, you can put your hand up to it, but if the IR thermometer comes back, especially we've got aluminum wires, this can be a big issue in terms of overheating, and thus degradation of the system. Okay, maintenance plan given here on page 413. So inspect modules for damage, address array shading issues. I'm thinking on the exam, they're going to break these out in terms of which one's for safety and which one's just for overall performance of the system. And they're going to say, which one is most important. And safety is always going to come first. Then the lifetime of the system, and then sort of the economics, I'm guessing, are going to come last. Yeah.
That PDF that comes with that study guide has everything.
Yeah.
And it has a lot of stuff that's not in this book.
Yeah.
So literally, when it comes down to it, be familiar with this book, but you already are from the whole semester.
Yeah.
Take that PDF, print it out, carry it around with you, and start studying now. You got, 3 weeks? Start studying now, read a little bit every day, and the test will be a breeze.
Yeah.
But there's a lot of stuff in there that's not covered in this book.
Yeah. So monitoring, I know the definition of that. Repeated measurement of electrical, we talked about that. What's coming in from each array. Environmental, you're going to know what the what your temperature fluctuations, and then batteries, which we just discussed at regular intervals. And the most frequent tests, it's monthly, but it says check the inverter, charge controller, look at the battery enclosure, and most of these will not take a whole lot of time. Equalizing the batteries might, watering the batteries might, and looking at specific gravity. So the batteries are sort of the most labor-intensive of all, and that's why, most people just go with grid tied. That could change very quickly with some of these lithium ions coming on board.
Handle a lot of the stuff for you. Like they'll do the overcharge for balancing.
Mm-hmm.
Whatever interval you program it, but typically it's like maybe every 2 months or so.
Mm-hmm.
It will overcharge the system. Whereas you may normally charge each cell at 2.45 volts per cell, it'll bump it up to 2.8
Mm-hmm.
once every 2 months. And what that does is kind of cleans off the cells,
Mm-hmm.
because you have those plates inside there that are, where the chemical reaction takes place, and those go away with time, but stuff builds up on it. So by overcharging it, it actually kind of blows that stuff off. Yeah.
Well,